Hello, sixth graders. Today we've got 9.5 and the last section in chapter 9, which is on mean absolute deviation, very commonly referred to as MAD, mean absolute deviation. Wanted to start today's video tutorial with a shout out to the two Jadens in class, Jaden Hoyt and Jaden Glaus. You guys are doing awesome in class. You are leading the pack right now and just being great students. So way to go. Good job, guys. All right, let's get started with today's lesson, and we'll start off with a little bit of vocab. And the section title, mean absolute deviation, has a few different, probably bigger vocab words that we need to first define. Remember, mean is the average. Deviation means if something deviates, when you deviate from something, you stray or you depart from the normal course of action. So here's this car. If it deviates from this nice highway, it maybe takes this dirt road or whatever. So it's when you stray or depart from a normal course of action. So the mean absolute deviation is an average of how much data values differ from the mean. So we're pretty much comparing your data values, your different data values, to your mean. We're saying, on average, how far away from the mean are they? How far away from the average are they? So it's kind of like an average of an average. Sounds a little bit odd, but we'll try a few of these out. So here is a nice little breakdown and kind of a step-by-step procedure on how to find the mean absolute deviation. But if you understand our definition, I don't really think that you need this, but I'll kind of go through it just so it makes sense for you. So step one in finding the mean absolute deviation is we need to know what the mean is. We need to figure out what the average is. Okay. I'll have to add in our data right here. But step two, you find the distance between each data value and the mean. And then you sum them and then divide by how many there are, just like when you do find the average. So for our first example, it says you record the numbers of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. So here is your data. In the first scoop, there is 1 raisin. The second scoop, there's 2, 4, 4, and 5. So these represent, again, the number of raisins in 8 scoops. So on the first scoop, you only had 1 raisin. On the second scoop, you had 2 raisins. On the next scoop, you had 2 raisins. It might not be in that order, but obviously I listed least to greatest. Okay, so the first step is to find the mean. So let's average these numbers. 1 plus 2 plus 2 plus 2. So 2, 4, 6, 9 plus, let's see, this would be 12 plus 5 would give me 24. And to find the average, I divide by how many? Well, there were 8 scoops. So my average equals 3. 20 divided by 4 would be 3. Okay. Now, what I'm going to do is find the distance between each data value and the mean. So in other words, I'm saying, how far away is each one of these points from 3? Well, 1 is 2 away from 3. So, right. So this was step 1. Step 2. 1 is 2 away from 3. 2 is 1 away from 3. 2 is 1 away from 3. This 2 is 1 away from 3. 4 is also 1 away from 3. 4 is 1 away from 3. 4 is 1 away from 3. So I should have 6.6 number ones, because these are all 1 away from 3. And 5 is 2 away from 3. Okay, so that's finding the distance between each data value and the mean. So how close are each one of these data points to the mean? Next, find the sum of the distances in step 2. So I'm going to add these together, and that'll give me 2, 4, 5, 6, 7, 8, 9, 10, and divide by how many there were. So that's the third step, and then the fourth step is divide the sum by the total number of data values. There's 8 data values. So 10 divided by 8 will give me 1.25. And there is my mean absolute deviation. So what does that mean? That means that the data values, these original data values, differ from the mean, differ from my average by an average of 1.25. And that would be 1.25 reasons. Okay. All right, go ahead and pause the video now and try a mean absolute deviation problem on your own. Right. You should come up with a mean absolute deviation of 4.25 when you do this. Okay, and then interpret the meaning. Okay, that means that the data values, these data values here, differ from the mean by an average of 4.25. All right, let's try another example. And in this real-life application, it tells us that the smartphones show the numbers of runs allowed by 2 pitchers in their last 10 starts. Okay, so it looks like we've got one pitcher here, Mendoza, and we've got Rodriguez here for the other one. All right, so it says find the mean, median, and mean absolute deviation of the numbers of runs allowed for each pitcher. Okay, so let's see. Let's first do for Mendoza. And here are the runs allowed. And I'm going to start by listing it in order, least to greatest. So I have 1, 2, 3 zeros. 1, 2, 3 zeros. My next smallest number is 2. And I've got a couple 4s. And I've got a 5. And 2 6s. And an 8. All right. So remember that when you're taking when you're trying to find the median, your numbers have to be listed from least to greatest. So that's why I did that. So I'm going to find the middle number. Work my way towards the middle. One small, one big. One small, one big. And I get to 2 middle numbers. And it's 4. Well, what's in between 4 and 4? Well, that's 4. So the median is 4. Okay. How about the mean? How about the average? So I'll take and add up my numbers. So 0 plus 0 plus 0 is 0, plus 2 is 2, plus 8 is 10, plus 5 is 15, 21, plus 14 would give me 35, over the number of starts, and that was for 10 starts. So 35 divided by 10 would give me 3.5 for my mean. And then lastly, I'm looking to find the mean absolute deviation. So how far away from 3.5 is each one of these data points? Okay. So 3.5 is 3.5 away from 0 3 times. So 3.5 plus 3.5 plus 3.5. If you can't tell how far away it is, all you really need to do is subtract. So if you're like, well, I don't know how far away 3.5 is from 2, just take 3.5 and subtract 2, and you should come up with 1.5. 3.5 is only a half away from 4, so that occurs twice. Half and a half, or 0.5 and 0.5. It's 1.5 away from 5. It's 2.5 away from 6. Sorry, I switched to commas. They can be additions, adding signs, because we're going to add them. And then how far away is it from 8? Well, again, take 8 and subtract 3.5 if you don't know. That'd be 4.5. Okay, we need to add up these numbers now. So 3.5 plus 3.5 plus 3.5, you get the idea. When you add these all together, you should come up with 24. And then when you take 24 and divide it by 10, the number of starts we had, you'd come up with 2.4 is your mean absolute deviation. So again, the mean absolute deviation tells us that the data values differ from the mean, and in this case, they differ from the mean by 2.4. So these values differ from this mean by an average of 2.4. In this case, we'll be talking about runs. Okay. Now we'd have to do the same thing for Rodriguez, the other pitcher. Okay, so why don't you go ahead and pause the video and see what you come up with for the mean, median, and mean absolute deviation for Rodriguez, please. Okay, so when you list your numbers, you should come up with a mean of, well, it actually is the same. It's 3.5. The median is also the same at 4, but the mean absolute deviation is 1.4. See, it differs by a whole 1 then compared to Mendoza. All right. So what does that actually mean? That's kind of where we get to when we get to letter B. It says, which measures can you use to distinguish the data? And what can you conclude about the pitchers from this measure? So you cannot use the measures of center because they're the same. So we can't use excuse the bell there. We can't use the mean or the median because they're the same. So we need to be able to look at the mean absolute deviation. So the mean absolute deviation for Mendoza is 2.4 and Rodriguez, it's 1.4. So what does that mean? That means that Rodriguez has less variation. Okay, write that down. Rodriguez has less variation. Using the mean absolute deviation, you can conclude that Rodriguez is more. That means that Rodriguez is more consistent than Mendoza because each one of the data points is closer to the mean than it is for Mendoza. Okay. Anytime you have a smaller mean absolute deviation there's less variation and your data is more consistent. All right, last one here. Please pause the video for this on your own example and try it out. All right, it says Mendoza allows 4 runs in the next game. How would you expect the mean absolute deviation to change, and explain? Well, the mean absolute deviation will increase. Or, excuse me, I got that backwards. Mean absolute deviation will decrease. And why is that? Well, the new distance between the new value and the mean is less than the mean absolute deviation of 2.4. The new distance, which is 4, how far away is that from our mean absolute deviation? Well, our MAD was 3.5. So it's only 0.5 away. All right, which means that 0.5 away is less than the mean absolute deviation. Excuse me, all sorts of interruptions here. It's less than the mean absolute deviation of 2.4. So the new distance, 4 runs allowed in the game, is only 0.5 away from our mean absolute deviation. And that is less than our current MAD, which was at 2.4. So that will bring our mean absolute deviation down. That will decrease it. All right, that concludes section 5 here for mean absolute deviation. Again, essentially it is an average of how much our data values differ from the mean, or kind of, some people like to say, an average of the average. Well, kind of, but I think you kind of get the idea. So let me know if you have more questions. I'll be glad to help. This wraps up chapter 9. Good luck with your assessments, and I will see you shortly.